Question 8. The diagram shows the circle with the equation, this one here. The chord AB of the circle intersects the positive y-axis at A and is parallel to x-axis. Find by calculation the coordinates of A and B. Now that means I need to solve these two equations simultaneously. When you look at this one, this line here, okay, it is intersecting with this curve here. So I'm supposed to solve the equation of this one with this one of the circle. But then since the circle here is intersecting y-axis, and also it is the same point, it intersects with this line AB. So I will begin by, first of all, the center. The center of this circle is going to be 2, 0. So maybe it is around here, 2, 0. Then from that center to A there, let me make it dotted. This is the radius of that circle. Okay, the radius, which radius will be equal to the square root of this 8 here. The radius here is equal to A here, the x coordinate is 0 because on y-axis x is 0, but then there is a y coordinate we don't know. Okay, and then B here has gotten an x coordinate here which we don't know, and then the same y coordinate as A. Okay, so the radius is going to be the square root. I'm going to use this and this. So we shall have 2 minus 0, the change in x, then plus, this is 0 minus the y. 0 minus y, then squared. This one is equal to the radius. Remember, it is square root of what? Of 8. When I square both sides, this one, of course, will disappear. And then we shall have 2 squared here, that is a 4. Then plus, here we shall have y squared, then is equal to 8. And then we can have y, which is equal to the square root of course, 8 minus 4, that will be a 4. And then we get plus or minus what? 2. Okay, so meaning we can have this line here and then this other one here, you see. But that one wasn't given for the negative. So we shall have y, which is equal to 2. So we shall take the positive. This therefore implies that the coordinates of A are 0 and then positive 2. Okay, then after that, I will go to this equation of this circle, x minus 2, bracket squared, then plus y squared, which is equal to 8. Now, we have this line. Now, this straight line here is y is equal to what? 2. We have seen it is 2. So when we solve it simultaneously with this one of the circle, so just put a 2 where y is, and then we shall have x minus 2 squared, then plus 2 squared is equal to 8. When I take this one here, remember it's a 4, so 8 minus 4, that one will give us a 4. So this one here is going to be a 4. Then when we take the square root on both sides, this one is actually minus. Then we shall get square root of 4 is plus or minus what? 2. Okay, when we take the square root. Now, our x is going to be equal to 2, then plus or minus 2. So we shall get x1 as 2 minus 2, which gives us a 0. And then x2 is going to be 2 plus 2, which gives us a 4. Now 1x is 0, which we have gotten here where this line meets the curve, you see? And then the other one has to be the 4, which we have gotten. So that therefore implies that the coordinates of B are going to be 4 and then 2. Remember, A and B have the same y coordinate since that line is parallel to x-axis. Then part B, find the volume of revolution when the shaded segment bounded by the circle and the chord AB is rotated through 360 degrees about the x-axis. Now, when we go back and check what we are having here, this one here rotated about the x-axis. So this region is actually between two equations. So between that of the curve and then that of the straight line. Remember, we get the one which is above. We have to get the volume below this curve here. Then we subtract the volume below this line here. Okay? So that's what we are supposed to do there. So in my simple sketch, I'll come here and draw something here. So since this is 0 and this is our A, then we have a straight line here, okay, which is y is equal to 2. And then this is x, so we need this region here. We need to know the x coordinates. Of course, here, this one, we are having point B here, whose x coordinate is 4. So, of course, this one is 0, 2. So this is a 4 here. So meaning that to rotate this one, of course, you know that this is pi. If the region is in between two curves or a line and a curve, then you get the one which is upper, then minus the one which is lower. But you are getting volumes of those. And this one is coming from the volume of a cylinder, okay? Because you have something like this and maybe something like that. So when we pull out something here, it is going to be that cylinder there. And that cylinder is going to have the radius. So the radius is going to be the change in the y. You see that? Change in the y. Now, the radius here is equal to the change in the y. And then this one here is the height. So the height is going to be the change in x, because you are pulling out a strip and there is going to be a certain small change in the x values right from here. So our y2 maybe is the one that is up. That is the equation of the circle. So in that equation of the circle, we need, remember, if you check here, it is here. And we are supposed to make this y squared the subject of the formula. So it is going to be this 8, then minus this one here. So I will have pi here, then 8 minus x minus 2 squared. Then we subtract y1. This is the one before. I mean the one down here. That is y is equal to 2. So I will just put minus 2 squared like this. Then dx from the x coordinate here is 0 and then here it is 4. So 0 to 4. Then from here, we can integrate. This is 8 minus 4. We get 4, right? So we shall get 4 minus x minus 2. Actually, if you want, you can expand the whole of this, but I can integrate everything straight away. Now, in my integration, I'm going to have, remember, when you're starting to integrate, you remove the integral sign. So you can see that here, I'm not bringing it back. Now, when you integrate this one, raise the power by 1, you divide by the new power, that will be 4x. And then here, x minus 2. Then power, this will be 3, divide by 3. And then times the derivative of whatever is inside here. So that will be a 1 here. And then we put the limits 4 and then 0. Then we shall have pi, then 4x minus, actually let us put the limits right away. So 4 times 4, then minus, this will be 1 over 3 into 4 minus 2, then cubed, And then from there, we subtract. Now put 0. Of course, this will be 0. Then minus, we shall get a third into, of course, negative 2 here, power 3. Then we shall have, well, I think there is something I forgot to tell you here. Volume of a cylinder is pi r squared h. So that's why we have the pi here. Then the r is the y, the difference between the two y's. And then h is the change in the x. So that's why you're seeing dx. Okay. Now, continuing, we shall have this one as 16 pi, then into, this will be 16 minus, this will be 2 cubed, which is 8, so minus 8 over 3. Then from there, all the power of a negative is always a negative, so negative 8 here times the negative here, it becomes a plus, but then there is a negative here, so it will be minus 8 over 3. So this one will be minus 8 minus 8, that is minus 16. So we have 16, then minus 16 over 3. Now this one simplified, we shall have 16 times 3, that will be 48. Now 48 minus 16, that one gives us 32. So we shall have 32 over 3, then times the pi. So we have 32 over 3 times the pi. That will be our volume. Do they want it as exact or not? They said find the volume of, so they never said whether it is exact or no. So you can write this one like this, or to 3 significant figures, okay?